Broadcast started. All right, so the extension problems. Given two vectors, how would you find the resultant vector? How would draw two vectors and the resultant vector? Um, I believe all we need to do for that is just, have you done any, did you do the vector homework yet?
Yeah, I did all of it.
Nice. So yeah, you know, so you're gonna be a master at this. I should just let you do all the talking.
Yeah, other than I'm bad at explaining when there's not like an actual problem to do it with numbers.
Oh yeah, yeah.
Like, I don't know about you, but like when it just asks me that, like I can't think about how to do it without like there actually being the problem with the numbers to do it on.
Oh, you're a numbers guy. You like the math stuff. But I think it's gonna look like we had. So let's say we had two vectors like this.
And it depends if you have one vector or two vectors, right? I mean, you usually have two, but
Yeah, if it was just one, they just
at
be
least in
that
the
one.
homework, it was. So you add the x and x values together, and then the y values together.
Yep.
What do you do after that?
And then like, since we're not giving any numbers here, you just know that you're. Yeah, you just get something. You know, it's going to be a bigger resultant vector somewhere between the two, depending on if they're both equal or one's bigger than the other one. So like this one, I drew a little bit more tilted to the bigger vector, but it's still kind of in between them. Yeah, that's what I do anyway. But when you have the numbers, like you were saying, yeah, you add the x and the y's. And let's see, I think there's one like that in the homework. Was that number 11?
Let's see. There's a lot like that in the homework where you do that. And then you take the x value and you square it, and you put the y value and you square it. And so it's like square root of x squared plus y squared.
Yeah, and that'll give us the magnitude, right?
Yeah, that gives you the magnitude.
I think we'll actually do that for this next one here with the stump.
Oh, yeah.
So if we've got horses, so we've got 65 degrees between them. Okay, so we've got tree stump, bam, bam. (300, 200, 65 degrees). So we have something like this, right? The two horses pulling on it.
Yeah.
Really great. And then, like you were saying, to find the magnitude.
I'm gonna send Susan a text.
Okay. And what's that law called? Like the parallelogram law?
Something like that.
Then we can.
I mean, there is a law called that, I think.
Yeah, because then let's see. So if we got alpha So we draw something like this, and then we need to figure out what those angles are, the alpha and beta angles there.
Yeah.
I don't remember how to do that part exactly, though. I don't think there's anything quite like there was a question about the parallelogram law in the homework, but it was just like, what's this law called? It wasn't an actual problem. So what would we do for that? If we know this is 65, oh wait, okay, so maybe do all these angles have to add up to 180?
If it's a triangle.
Okay.
Triangles is just 180 degrees.
Yeah. Okay. Yeah. So if both of these. Okay. So since we split this, since we kind of made a triangle here, right? We split we've got like two triangles here, one right here, and then one right here.
Yeah.
We can figure out these angles. So we know that. Can we say that's split right down the middle then, or?
I don't know if you can say that. I mean, it'd make it easier to find the angles, but I don't know if you can necessarily say that. But if it is, like, it depends on, like, the side angle, the side lengths, because, like, if it's, like, perfectly symmetrical all the way around, you could say that.
Right.
But if it's longer on one side, the angle would be greater on that side and shorter on the other side. So you couldn't really say that, I don't think.
Yeah, I think you're right. So how do we go about solving that? Do we do like what do we do?
Let me see your drawing again.
My drawing? Oh yeah. Mm-hmm.
Okay. So if we look at the, let's see, so 300 and 200, yeah, so we can't say that, wait, other than the other sides are the same, just reversed. So maybe?
Maybe. I was looking at the in the answer key, it shows that we should get, like you were saying, we can't just split it down the middle. Alpha and beta are different values.
Okay.
Well, I'm still not. Okay.
We need to figure out what those side angles are. Like the angles that are on the sides of that.
Oh, okay. I think I know what we got to do. So we've got, like you were saying earlier, we have to, those triangles, the angles in the R2 triangles we made here,
Yeah.
will add up to 180, right?
Uh-huh.
So if we take 180 and subtract 65, that should get us 180 minus 65, 115. Okay, perfect. So when we get 115, wait. Yeah, so if we do, here, I'm going to write out, then I'll show you real quick. If we do something like this. Okay, so if we, I don't know if you can see that, but if we take 180, because we know one of the angles already, right?
Yeah.
65. And so if we solve for what is that? The gamma or the other angle,
Yeah.
then we get 115.
Okay.
And then we know that, and then we can do oh yeah, okay. So then we can do the r squared equals 200 squared plus 300 squared minus 2. So I just have this as an example problem in my notes from the resources.
Oh yeah.
And it's the exact same one. So this is what I have for, well, I'm going to send you a picture so you can look at it better that way.
All right, sounds good. I still have nothing from Susan.
Late FHE.
What?
Late FHE.
I guess.
Okay, sent. Okay. Did I get to you?
What?
Did that picture get through?
Not quite yet.
Oh. I did send it, right? Let's see. Yeah, okay. Yeah, okay, just sent.
Yeah, pictures take a little bit sometimes.
Yeah. So I can't really tell you why exactly we do it like this. This is just one of the things they had in the example problem. Or in the resources.
Yeah. Here we go.
But this is what they have for it.
Oh yeah, this is like exactly the same, isn't it?
Yeah. Okay.
It's interesting how the numbers line up almost exactly.
Yeah. Yeah, so I got that. Yeah, I guess I couldn't tell you why exactly we do it like that, but it works.
Yeah. Okay, couldn't to find like the hypotenuse of both triangles. I think we need to find that, right?
I think we just need to find. Let's see, what is it? It looks like he's just asking what the magnitude of the resultant force is and what is the angle between each course and the resultant force. I don't think we actually need to find the hypotenuse. I mean, you probably could, but I'm not sure.
Yeah, I think it'd be just both those tangent, like 200 over 300 tangent.
Okay. And then what do we do with the hypotenuse?
Yeah, I hadn't gone that far yet.
Okay. No
I figured it'd make it easier to figure stuff out since you'd have more information.
Yeah, it probably does. There's probably several ways to solve this.
Yeah.
Did you get those answers yet?
Not yet.
Okay, no worries. Take your time. Okay, so Jay has an appointment, so he's not going to make it today.
Okay.
He wants to know if he can meet or talk with us after. Sure. I won't be through the video thing, but.
Okay. Let's see.
What part are you at on the problem?
I'm trying to find the angles. But, for some reason, I can't remember the formula quite for doing that.
If you look at step number 4, that should give us, with that we can solve for the alpha angle. And then we can just subtract that from in the number 2 equation. We can just plug in that for alpha, that value for alpha, and then solve for gamma. In the picture I sent you.
Oh. Okay. So that would make the angles be for alpha would be the 25.24.
Yep, that's what I got.
And beta be the 39.76.
Yeah.
Okay.
Cool.
I believe that's what it's asking for. So.
Yeah, that's what I've got here. It wants R, alpha, and beta. And I got number for that. So it gives us an example for number 3. It gives us like the formulas we're going to use in an example.
Yeah.
For A, I tried doing it, and I could only get the second equation. I figured out the answer to that one, but I don't know how to do the other ones.
For the second one, or the first one?
For
the r equals square root of x2 plus y2? Or is that where you got stuck, or was it the one before that?
The one, at number 3, it's got A, B, and then A again. The second A, I got, I couldn't get y equals 3x minus 2, but I got x squared plus y squared equals 9. I figured out how to do that one. Does that make sense? Because it shows us it just kind of most of that is just talking to us about stuff, and then it gives an example how to do one of them.
Yeah. Okay. I think you would solve for y and then solve for x.
Okay.
And then you would plug those values in for the x and y values in those equations.
Okay, so it's already solved for y, and then we can solve for x.
Yeah, I think that's how you do it, because
Let's try it. Yeah, let's see what we get.
Because right now those values are unknown. So.
Okay. So for x, I got y plus 2 over 3. Then we plug that into the r squared r squared equals x squared plus y squared.
Well, did you get what x equals?
Yeah, I got x
and
equals
y equals.
Yeah, I got x equals y plus 2 over 3. And then y it's already solved for, right?
Yeah. This is going to be an ugly number.
Yeah, in the answer key, it looks like. What the heck?
Yeah, let's look at what they did.
Let's see.
And what time do you have to go at?
Probably in about 5-ish minutes.
Okay. How's the baby doing?
She's doing good. She's still in the hospital, but she's pretty much just independent. She just still has a feeding tube right now, so she's still learning how to breastfeed, but she's doing really, really well.
All right. So you haven't had as many sleepless nights yet?
No, not yet, because she's
there to come.
Yeah. Yep. But right now we're kind of, it's like, it's kind of nice because we have a permanent babysitter, so we can go see her and then we can go do other stuff too.
Yeah.
But we really like her to be here at home with us.
Yeah.
Okay, well, I'm not having much luck plugging those answers into the equation.
Yeah, I'm not quite sure how they got that equation.
I don't really even understand their example they gave. I'm not sure.
Okay. So look at the beginning for the formulas.
Mm-hmm.
So x equals r cosine of theta.
Mm-hmm.
So if we plug those in to the x and y values in that problem, like just looking at what they have as their answer, we could take it would be the x would be 3 cosine of theta, and the y would just be sine theta, and then it'd all be over the -2.
Oh, I do see that. Okay, because r equals. And which one are you looking at? You said at the beginning of the formulas, so you're looking at x.
The x equals r cosine of theta, and the y r sine of theta.
Okay, so y is just going to be, like you said, y is just going to be sine theta, and then x is going to be 3 cosine theta.
Yeah. Well, it has a -3.
Right. Oh, yeah. Oh, but we are solving for r too. Okay, so yeah, so we're trying to get r. And
the -3 is the only part that I'm unsure about.
So I noticed that it says given r or theta, then use these ones. If you're given x and y, then use these ones. So is that maybe some of it we have to do somehow?
Maybe.
Because are we given? But what does it mean when it says given? Does that mean they're just in the equation? Because I mean, none of these have. Well, that one kind of has r.
Yeah, the bottom one has an r.
So if we did y equals, how could we put r into that equation? Because that's what it wants. It wants r. What is r equals x squared plus?
Hey Connor, did you text the group this morning?
I did not.
Yeah, Susan just got my message.
No.
And my phone is broken again.
She just got your message? What do you mean, like just now?
Yeah. She's like, I just got this. Did anyone text the group?
No, but we had agreed to meet at 9 every Tuesday and Thursday, so I thought we just.
Yeah. We did change that when we met at like 11.
Oh, really? Oh, sorry, I was not aware.
But I mean, we didn't like officially change it. We just did it. So.
Oh, so it looks like Jay does want to meet up for real and do the group meeting. I don't think I'm gonna be able to do that later today, but I could just send him the video.
Yeah.
So maybe should we somehow put I'm not sure. I just don't understand how they put r in there. Like what you were saying, I can totally see how you plug that in there and you get using those upper equations, but I don't understand what makes them able to just set it to r. Or how you even got the 3 underneath the 2.
Yeah.
Well, let's jump down to number 2 and maybe work into that one. It'll help it because this one, the number 2 is pretty straightforward. Maybe that'll help us understand the other one.
Maybe we'll have Susan join for a minute. I don't know.
Because in number 2, we know that x squared plus y squared is equal to r squared. So we can just make those two variables r squared. And you just solve for r and get plus or minus 3.
Yeah.
So that's straightforward. That's pretty easy substitution. So is there something like that we can just do where we can let me make what equals r? Square root of stuff equals r. 4r squared. Yeah, I don't know. I'm gonna have to check this out later. I gotta head out now.
All right.
But good job on the other stuff. I think we did good on the other stuff.
Yeah.
All right. Well,
I'll talk to you later then.
Sounds good, dude.
Ciao. Good.